It's all hands on deck as the shipping industry works to reduce its carbon footprint, a task that in the next few years will likely lead to more innovation than the industry has witnessed in the last century. A sustainable future is at stake, and there are regulation deadlines to meet.
This is the future of how engineering is going to be done. The traditional review, traditional calculations on spreadsheets is not going to cut it for the new stuff that's coming up.
At ABS's world headquarters just outside of Houston, Texas, Jan Chow works in this impressive high-tech design room, where he leads a team that tests various decarbonization solutions virtually.
We start with a baseline model of an existing vessel. What we do is we take the propulsion system specifically, and we build out a simulation model in a virtual environment. And by doing that, we're able to account for many different phenomena that are happening in the physical world, in the virtual world, and then we can make changes to it.
3D simulations will not only show new shipbuilders how to reduce the cost of future conversions set by regulators, but the technology also reveals how existing vessels can be converted.
I think like any new technology, as people start to learn about simulation, there's initially some skepticism, and then there's a ton of excitement when they really see what the power of this technology can bring to bear on the challenges that they're facing.
Using simulation, the ABS team is investigating new solutions. It's a vision led by the chairman, Christopher Wernicke.
The solution to decarbonization is really going to be a hybrid solution. It's going to require an understanding of the different fuel pathways on the vessel. You need to understand the various supporting technologies, whether it's electrification, whether it's carbon capture, whether it's just next generation of hull resistance. And it's going to also require an emphasis on vessel optimization. Simulation allows us to bring all those together.
ABS has joined companies Wärtsilä and Hudong. This three-pronged joint development project will do a deep dive looking for better solutions, more ideas, because it's clear to everyone involved better collaboration is needed to design and build ships over the next 25 years.
In this project, we have Wärtsilä, which is a vendor or equipment manufacturer. We have the shipyard, which is Hudong-Zhonghua, and we have a classification society, which is ABS. So we really can complement each other. We are going to study the various new decarbonization technologies, and we're going to use a new methodology based on multi-physics modeling simulation to study the system performance. And this is a big deal because this new technology or methodology can be applicable to all aspects of the value chain and to study the increasingly complex systems for the maritime industry.
Wärtsilä's role in this joint development project is to develop a propulsion power system that supports the target of reaching IMO's 70% CO2 reduction. The future systems will be highly integrated, electrified, and modularized to provide the needed flexibility for all systems to work together to achieve an optimal system efficiency. 2050 may sound like a long ways away, but if one considers that the vessel lifetime of approximately 30 years, it's important that we're designing a vessel today that shows a clearly flexible, future-proof pathway towards reaching IMO's 2050 targets.
Different cylinder pressures are connected to the engine load by...
A lot of the secret around using simulation to really solve problems is having a good validation set, having a good verification approach, and those are the types of things that we're building now at ABS.
And with all hands on deck, there is a reason to be optimistic for the shipping industry and our environment.
The challenge for the industry is begin to rationalize and understand that and recognize that the solution is going to take, in some ways, technologies that have not yet been developed, and to be able to understand their readiness and to be able to see whether they can scale up safely, I think is something that has to be really looked at and worked on today, even though we're talking about outcomes that we want to achieve 20, 30 years from now.